The result is clear. Although it's different from the slide, just the representations of the result is different. In the report and your slide. We'll discuss about this later. That is good. It's logic. Only the problem is that you spend half of your report talking about background. And I understand your work not because of the background. So I suggest that you have to reduce the volume for the background. You talk a lot about many other things, but spend only half your report to talk about your work, your contributions. It's better that you focus on your contributions. The background, we can still understand some key points. Other is not very necessary for me. You spend some part to talk about host institutions and okay, that's good, no problem. But a few part for the tools, sand, scorn, etc. is quite not necessary. Okay. Now to understand more about your work, generally I understand that you implement some modifications for ANS lines in order to reduce the running time of the system. Right? Yes?
Would you repeat it?
I mean, you modify, you implement the FaaS runtimes with Intel SGX, but for me it's implement ANS lines with Intel SGX. Yes.
So the Nline is actually an FaaS. So when I implement the Nline runtime, it also could be implement FaaS runtime.
Yes. Because I see in your results, you compare the ANS lines with and without Intel SGX.
Yes.
And in the figure 3.4.1 is the ANS line with highlighted modification changes. And this change is to adapt to the Intel SGX.
Yes.
Okay, good. The figure 3.2 and 4.1 is actually identical, except for the color, the border.
Yes.
And we know that the modification should be there, but what exactly it is missing. It's not. I cannot find this information very clearly in the report. Today I see in the slide. You added in the slide. Can you open again slide 11?
Yes.
Yes. That's it. This slide 11 is not in your report.
Yes, so that is almost like in the report.
Almost like, but it's better to understand.
Yes.
So I suggest that you can add it into the report. And you can remove the duplicated one or revise some figure to clarify what modification that you did with ANS line. And because I don't understand that part of how you modify ANS line architecture, so it's not very clear to me how this modification can enhance the security and the runtime.
So the Intel SGX is a technology from Intel that offer for cloud computing model to encrypt the data is like a hardware encryption for the data that in small in the enclave. So any code that put into the small allocation of the CPU will be encrypted and not accessed by any other third parties or the group.
Okay, so you can come back to the architecture of endpoints and the Docker file and the SGX, not that one. The one you mentioned about Docker Composer. Orchestra workflow definition. Okay, the previous one.
Previous.
Previous one? Yes, that's one. From what you explained about the data in the CPU, okay, computing. How SGX improved the computing process. Can you explain this here in this workflow? Which part show that the SGX encrypt the data, make it safer, more secure?
So any task that exists encrypted is will be in the enclave, and when we initialize global variable inside the enclave, the untrusted zone could not only access to it by having an O call like I mentioned earlier. And if their root access like admin device, they cannot directly make an O call because that will only that O call can only be called by the application. And so this variable will be encrypted inside the memory zone, inside the CPU zone, which is called enclave. And for all the rest, it also put inside the enclave. So even the code, and so for that data cannot be accessed by the admin or the hackers that conduct the attack.
What is so the difference between the previous system and the after system with the Intel SGX is the encryptions only?
Yes.
Does this change anything in the workflow?
We have to in the workflow this setup is almost not needed in the original NIV because you could always declare it inside the app and just run it. However, we have to surpass this memory context set up inside the enclave, or it will not run because the Intel SGX don't have memory allocation.
So this is the modifications. The reason here is that you have only the workflow, the after modified, the modification versions of the workflow, but not the previous one. So the modification is not clear. It's not clear. So I suggest that for the figure 4.1 like this, you can replace it with the previous workflow. And you can highlight already the red in the figure 3.2, the modification. It's without the, as I said to Thắng, without before, we don't know what is the modification will be changed. Right? Now come to the result. So mainly it's about the encryptions of SGX. Do you have the table here? The table of results. I'll come back to the figure. Slide 19. Yeah, 19. Yes. The time course. Can you explain before and after what happened and why?
So the green bar is the NI, the origin of NI, and the orange bar is the after the modification with Intel SGX. In the table in thesis, there is a table that have a list of events. However, we only made it up to the first execution event. So we will take the execution event, which is 2.08 seconds. And
This result is different from the result.
no, it's not, because in the original NI, it reached a full complete state, and however, with the after modification, we only made it up to the first execution event. So it will only, so I will only compare them to the origin. So I will compare only the first execution event.
First executions event. Which event is the first executions?
Is 0x 0040005.
You define it, or it's some kind of standard?
We define it, but
I don't notice in your report. And lines, because I see the number is quite different. Is text. Okay, so the end lines, the original one recast 2.03 seconds to 2.04 seconds to reach the first execution event.
yes.
Yes, and the end line with SGX, Intel SGX, it takes us 2.5 seconds to 2.7 seconds to reach the first executed event. 2.5. 2.5
5 is 2.7.
All right. Again, the first execution is 0x00 what?
4005.
4005. The last event appear in the table.
Yes.
You have to mention this executions. All right. First. Now, in SGX you add some security, the encryptions, okay? And because you don't have the table here, do you have the table? The result here?
No, but I could open the thesis.
Or if you still remember, what are the confidential data? What executions? What event is the encryptions or the security along this event in the table?
So all the first input and output are the initialized state. Why we start putting them in the Intel SGX, we start from the all input, or the second input and output.
Second,
Input and output. SWEAT is the file that we created when we.
Yeah, it's a service when the service is called.
Yes.
It's not very clear. So, in short, we can figure out which of these events is for security. So logically, I can find some events that occur when you run with SGX, and this won't appear. It doesn't appear in the original result. Okay, I ask this later because I see the service for the original version is not. It's more than the other. It's quite hard to explain. Okay, thank you.
I do have only a very small question. So you say that the integration of Intel SGX into the Antium to enhance the security, right?
Yes.
But here the result I see only the time cost, right?
So
This is there any other metrics that you will survey to confirm that okay? So Chrome can help to enhance security of the FaaS.
So about this good question. We conducted this project with a very sparse document, and to all the documents I read, there's no way to pen test which security is turned on when we apply the Intel SGX, but usually they use the performance benchmarks to compare with their original work.
Okay, thank you. Well, so that's all for me.
Thank you.